In this video, I'm going to go over density and how we calculate it. Density is actually a very important physical property that we have to understand because the interesting thing is that it doesn't really matter how much of a particular material you have, it's still going to have the same density. It is actually an identifying property of that material. So let's say that I had gold and I had a tiny little piece of gold. Well, gold has a particular density. I could prove that I have gold by finding out what the density of that material is. If I had a huge chunk of gold, it's still going to have the same density. So it's a really important method to identify what our matter is, because the density of a particular element or the density of a particular pure substance like a compound is always going to be the same density. It doesn't matter how much of the material I have. So we have to understand that density is going to be related to anything that is matter. And so we have to remember that matter is anything that has volume and takes up space. So density is how concentrated that matter is. So for example, if I have a cube of something, when we're thinking about density, it's how tightly compacted all those molecules are in that particular area or that particular space. So we're going to use two pieces of information in order to figure out density. We're going to need to know the mass of the material, and we're going to need to know the volume. So in that cube of material, if I have a lot of molecules and atoms all compact together, it's going to have a greater density because there's more compact into that volume. If those atoms and molecules are more spread apart, then it's going to be less dense. So I have an equation here for you that density is equal to mass divided by volume. When we are finding the volume of solids, we're going to use centimeters cubed. And so a solid's density would be written in units of grams per centimeter cubed. Liquids are going to be recorded in milliliters, and sometimes we're going to have to use the displacement method in order to find the volume of a solid. So we might actually use grams per milliliter for a solid as well. But the interesting thing is that 1 centimeter cubed is actually equal to 1 milliliter. So those two are equivalent to each other when we're using the displacement method. Now there's also, sometimes you might have to find the mass and I give you density or volume, and sometimes you might have to find the volume and I give you mass and density. Different things, you're going to have to rearrange the equation mathematically. There is a little trick. You can use a triangle where it goes dmv. The d is equal to mass divided by volume, and then you can see here in the triangle that if I want to find mass, I would do mass is equal to density times volume, and then if I wanted to find the volume, I could look at this triangle and go, okay, volume is mass divided by density. So you can do the algebra to rearrange the equation, or you can use the little triangle as kind of a little trick. So we can use density to compare materials. I have here ice, water, lead, and osmium. You can see I have the same volume of every single material, but each material actually has a different density because they have different masses. So the volume is remaining constant, but if I were to take the density of ice and take 0.917 and divide it by 1, the density of the ice would be 0.917 grams per centimeter cubed. The density of the water would be 1 gram per centimeter cubed. The density of the lead, again, I have the same volume, but it has a different mass to it. The density of the lead would be 11.3 grams per centimeter cubed, and the osmium's density would be 22.5 grams per centimeter cubed. When we have something that is a block, we can simply take that block and put it on a balance in order to find its mass. So this block has a mass of 79.4 grams. Then I can go ahead and I can find the volume by taking the length, the width times the height. So I would use a ruler and find length and width and height of this cube, multiply them by each other in order to get a volume of 29.8 centimeters cubed. So to find density, density is simply the mass divided by the volume. So I would do 79.4 grams divided by 29.8, and I get 2.66 grams per centimeter cubed. Most of the time, the material that we're measuring the density of in the lab are not perfect cubes. So we're going to have to use the displacement method. So I'm going to draw some pictures here. Think about when you get in a bathtub. When you get into a bathtub, the water level goes up. That's because you are made of matter. You occupy space. And so when you get into that bathtub, you displace or you push the water out of the way so that your body can occupy that space instead. The displacement method uses this process because the amount of liquid that you displace or push out of the way, that volume is the volume of your body. So if I have a material and it's an irregular shape, I can take a graduated cylinder and I can go ahead and I can record my beginning level of the water in that graduated cylinder. When I record that beginning level, I then put in my object that I want to figure out the volume of. However much the water goes up by, so I'm going to record my beginning water value and I'm going to record my ending water value. However much the water goes up by, that is the volume of the material that I put into the graduated cylinder. That is the displacement method. Even when you take some ice cubes and you put them into a glass of water, the ice cubes are going to push the water out of the way, and that's part of the displacement method. But there's an interesting thing about water. Water floats when it is in the solid form as ice. And most things, when they're in the solid form, they actually sink. But water is very special. It has a very interesting property, and you can see here that there are hydrogen bonds, and we're going to be learning about hydrogen bonds. They're a type of intermolecular force. We're going to learn this unit. Those hydrogen bonds are weaker and stronger in different forms, different phases of water. And so you can see that when water is in the liquid form, the molecules are much tighter compact, and so that means the water has a higher density, because remember, density is how compact the molecules are. As an ice, you can kind of see in the image how the molecules have now spread apart. And so water, when it's in the solid form, is actually less dense. The molecules are more spread apart in that volume. And so when something is less dense, it floats. When something is more dense, it sinks. So the water has a greater density than the ice cube does. And the ice cube, having a lower density, is floating above the water because the ice cube molecules are more spread out in their volume than the water molecules are. Since materials have different densities, we can also use density to separate materials, as well as to kind of figure out which material is more dense or less dense. So you can see in these images that we've got layers of liquids. In the first image, I've got oil and corn syrup. So you can see how the corn syrup down at the bottom, that has the greater density. So again, if something has a greater density, it's going to be down towards the bottom than the material that has a lower density. When we add in the red in the second picture, you can see how the red ends up between the oil and the corn syrup. So that means that that red water, that particular material, is less dense than the corn syrup because it's above the corn syrup, but it's more dense than the oil because it's below the oil. And then if we add in some green alcohol in there, we can see the green is floating at the very, very top. And so that tells us the green liquid is the least dense, and the most dense material down at the bottom is the corn syrup, and our other two materials are in between the densities of those. So we can use density to actually separate materials. We can also use density to put solid materials into our density cylinder, and where we've got the different liquids. And if we know the densities of the different liquids that we've put in, we can then put a solid in and see, okay, where does that solid go to? If it goes all the way to the bottom, then we know that it's got a greater density than our most dense material. If it goes into the middle material, then we know that that material, that solid, the green one, solid number 2, is going to be more dense than liquid 1 because it sank through liquid 1, and more dense than the water because it sank through the water, but it's going to be less dense than liquid number 2 because of the fact that it's floating above liquid 2. So we can use the concept of density to figure out which material has greater or lesser densities. So this is an interesting little at-home thing that you can try. If you take a can of regular soda and a can of diet soda, you'll see that the regular soda sinks It has a greater density because of the sugar that is used in regular sodas. Diet sodas use a different type of sugar, which is a molecule that is less dense and less compact. And so that sugar ends up that the diet soda is less dense and is going to float in the water, whereas regular soda does not float in the water.